All right, so let me show you something that I feel kind of dumb about. I don't know if I ever knew this. I think I might have known this sometime in the past, but I've forgotten about it. But look what Desmos can do. You can put in there one of these implicit functions. Now definitely, if somebody feels like you can solve this for y, please teach me, right? I don't know if you guys can you all see that? Can I zoom in on this? No. Yes. Can you guys see that equation right there? 0.2 xy squared minus 4 natural log of xy equals 2 cosine y. So again, if you can solve for y, teach me, right? Look at the picture. Look at the graph. Isn't that cool? It's a big foot. Somebody just standing on the y or just laying down on the x-axis, whatever. Now watch this. So this is so cool. I can't even tell you. Think about young Jeff taking this class in, holy shit, Jeff, 1991. Yes, 1991, before the internet was a thing. Yes? Oh my God. Oh my God. So we didn't have this shit, right? So there's no way in hell we could ever really, really know what these things look like unless we have a computer-generated image for us that somebody else had to do, right? We couldn't do this shit. Now, watch. Let me put a 2 in the cosine. Look at that! Sorry. I don't know if anybody else is like, has any like feeling like you got to jump in here and just play around. Just put shit in there, just see what the hell happens. Anybody feel that way? Let me make this a 7. Oh my God! It's got so many little islands. I don't know why, but the Drops of Jupiter song came in my brain when I saw this. Drops of Jupiter, holy shit. All right. Anyway, I'm sorry. So, if you want to just, you can obviously plug something in that you're working on in the homework so you can actually see what the hell it looks like. If you have to find a tangent line, you could put that in too. So I did this problem up on the board. Don't worry about it. So I have this thing. I did a problem. I figured out the tangent line at the point 1, -2. So I did the work up here if you're curious. And I found the tangent line was this, 2/3 x minus 1/8. So when I graph it, hey, look at that shit! You can actually make sure it makes sense. Yes? Maybe? So I feel really bad that I didn't even know. I can't even remember if I actually ever knew this. But this is so freaking powerful. I had no idea. So you can just make shit up, cosine of x times y squared equals, Jeff, do it right maybe, equals y minus xy. Oh, I didn't like that at all. I've done some weird shit to this poor thing. I've hurt the computer. Let's make it this. It still doesn't like it. Okay, how's this? It still doesn't like it. I don't have it on. Turn the thing on, Jeff. Okay, thank you. Let me get the first one I had. Look at this. Yes. Wait. Let me make it. That's not that so bad. Okay. Look at that. I think I was talking about one before that I was like, it would look like a diagonal sine thing. There you go. All right, I'm sorry. I'll stop. It's just amazing what you guys have access to now. God, I sound so old. All right. It's because you are, Jeff. Oh, yeah. Okay. So as you guys have now come in, more, if you need any of these 3 recent handouts, let me know. Oh, let me see. Logan. Are you out there, Logan? There you are. Nathan. Sorry about that. Alright guys, I've got the answer key for the practice test that I won't give to you yet. We're going to first do a few from this here. If you weren't here last time, here's the weird thing about section 3.9. Homework for section 3.9 won't be due this Friday, but you should do several of the first problems in there because I am going to put a very basic 3-9 type problem on the test. Does that make sense for everybody? So if you want to do all section 3-9 homework, you can. It's not due, right? Yes?
What section are you doing again?
2.8 through 3.9, not counting 3.8, that's extra credit. Right? So I could put a bonus question on there from 3.8. And 3.7 was never on in our curriculum for this course. So, all right, so it's 2.8, 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, 3.9. Sorry. Yes.
Which one was 3.8?
3.8's like natural sciences, calculus and the natural sciences, sort of. I only had 4 questions from there because it really depends on if you go which direction. You know, if you go into physics, if you go into chemistry, if you go into biology, if you go into whatever, it's going to be different applications. Calculus will then just be another tool, like solving an equation. And where can equations come from? Anywhere. So calculus can be used to do things because any problem could kind of suddenly need calculus to do. Yeah. So that's sort of the point of that is just what does it look like in other classes? What would calculus kind of look like in other classes? Or what kind of problems would require calculus in other classes? That's sort of like what that section is about. Yeah. Yes. Practice test. Anybody else need a practice test? So let's do this first, this worksheet here, if I can find a pen. Are you a pen? All right, let's see if you work. Okay. All right. I love the first problem, really jumps into it. So read the first problem real quick. Let's see if you guys get the idea. Okay. All right. So at one point, it's right overhead, right? So here's my plane. Yes? Leave my plane alone. So here I am. It's right overhead. And how far up is it? Yeah, 3 miles. It's going 300 miles an hour. Theta is the angle of elevation. What the shit would that be? What's the angle of elevation?
Like in the plane of the ground.
So, yeah, sorry.
At the 9th grade?
So look, this is 0. That's angle of elevation. It's the angle that I have to look up to see it. If I'm up in the plane and I've got to look down to see me, that would be angle of depression. Like it? Which is not related to psychology at all. Yes? No, at the moment, yes. Yes. At the moment, it would be 90 degrees. But that's not the snapshot I'm curious about, is it? What snapshot am I curious about?
After 6 minutes.
10 minutes later, right? Okay, stay with me. So it goes overhead. It's going 300 miles an hour. It maintains a constant altitude of 3 miles, right? 10 minutes later. Where is it? Somewhere over here, yes? Wah!
16 miles over.
So it's going 300 miles an hour. 300 miles an hour, so there's a few ways you can... 10 minutes is 1/6 of an hour. Okay, let me stop for a minute. Okay. Does everybody agree with that second picture I've drawn? So the first setup was just when it goes overhead, it's 3 miles above me, it maintains that height, right? So this is where I'm always curious if I have any flat earthers saying, that's proof of flat earth. Shut up. Relative to the curve, anyway, all right. Sorry. So now I'm drawing a picture about the snapshot that I'm in 10 minutes later. How high up in the air is it?
Also 3 months.
Still 3 miles, because that's what it says. It maintains the constant altitude of 3 miles. So I know this is 3 miles. What's this?
30. 50.
Oh, I got dissension in the ranks. 10 minutes, like I just said a minute ago. Now you see why I'm doing that, right? I need to know how far that is. 10 minutes is 1/6 of an hour. 1/6 of 300 will be 50, right? So whoever said 50 is correct. So this is 50 miles over. And where's the theta I'm talking about? Angle of elevation. So here's where I'm looking straight, and here's where I'm looking to the plane. So this is theta. Now, what is changing in this? This is the part where people kind of miss up. This is the snapshot, right? I really want this. All right. Is 3 miles changing? If I wait a few more minutes, will this change? So that is a true constant, yes? All right, what's changing? 2 things.
The bottom of theta.
Yeah, this is changing, right? Why was this 50 miles? Because that's at 10 minutes. So the minute is 10 minutes and 1 second, it's not 50 miles anymore, correct? So this is changing, and theta is changing. Okay. So what do you guys want to call the variable that represents this at any time?
X.
No way. Okay. All right, let me stop for a minute. This is, I think, one reason students don't like these kind of problems is there's a lot of pre-work before you can start actually attacking the problem. I haven't started doing shit yet, in a sense, but actually I've done everything that is completely necessary to do. So stop looking at it like the first sentence I just said. I haven't done shit yet. I've done a lot. I just haven't. Do I have an equation to work on yet? No. Have I done any calculus yet? No. Have I done any algebra yet? No. Have I done any trig yet? No. So who cares? I can't do shit until I know what the hell I am working with. So can somebody tell me what relates all the variables I'm interested in and the constants? Yes. So in general, what's the relationship at any time? Three to x. I like it. If you throw a number in too early, the derivative is going to be 0. Yes? If you throw your constant, your values in first, and then you take derivatives, every problem is going to be 0. What a bleak outlook. Right? So don't plug the specific values for your snapshot moment in too early. There's the equation. Now, can you give me in units, in symbols, what this is? We've got the variables defined. We got everything defined that we need to find on that picture. 300 mile an hour. What is that in calculus symbols related to what we've gotten drawn down there? You could do it.
300 miles over 1 hour.
No. What's that the rate of change of in my picture?
X.
There. Okay, so what's the calculus symbols for 300 miles an hour? This is the rate of change of x, correct? So what's the rate of change of x? What's that look like in calculus symbols?
dt over dt.
D who?
X.
dx
Yeah.
dt. What's miles per hour? Distance per time. dx dt. That's what this is. Did I know how to write that until I gave this a variable? No, I don't know how to write that until I give it a variable. Let me put it over here so it looks better. So dx dt, the rate of change of this is 300 miles an hour. In fact, that's where 50 came from, right? We knew it was changing by that much. So 10 minutes later, I could figure out what it is. Let me stop for a minute. You guys are looking at me so like, you're in your eyes. Please make sense. You guys semi with me? Now, of course, it's always one level to agree with what I'm doing. And then you go, I'm going to have to do this entire thing myself. Right. That's where you go, oh shit, I better really understand what the hell. I always try to show you my motivation for what I'm doing. because that's what you're going to have to do yourself later. What is it asking me about in symbols? What is the question in symbols?
D theta over dt.
Yes, good. So it's important to use symbols for everything they tell you and symbols for what they ask you. Based on the variables I have assigned. And theta, of course, is a good choice for theta, but for the angle, but you use whatever the letters you want to. I don't give a shit. Did it have to be x? No. Did it have to be theta? No. So it wants me to figure this out, but I know what this is. So what am I going to do with this? To kind of get something that's involving what I know and what I want to know. What do I do to this? Take the derivative. Now, you have an option here. I want you to really understand. Do you have to take the derivative the way that the function is set up? The way that the equation is set up? Can you rewrite the equation? Of course you can if you want to. Right? What kind of sucks about that? A little bit. Doesn't it suck that the x is on the bottom? So if you wanted to, you can bring it. It doesn't suck like that much. Not really. So it's up to you. You could make this x equals 3 cotangent theta. Is that, you guys see what I'm saying? Maybe? No? Do you guys, because I can multiply the x up, divide the tangent down, 1 over tangent is cotangent. I really want you to understand what you're allowed to do. If I have to take the derivative of an equation, I can simplify the equation first. That's something that the homework tried to get you to understand. I've tried to get you to understand, right? If you can simplify something, do it first. But we could just leave it like this, can't we? I mean, does anyone have a preference? It really doesn't matter. I would do that, yeah. So let's do that. Let's go all the way. Multiply the x up, divide the tangent down. Now let's do a derivative. That's dx dt, which is good because that's what I know. And what's the derivative of 3 cotangent theta? Uh-oh, this is one you got to know. 3 what? Good. So it's negative 3 cosecant squared theta times d theta dt. Okay. So this is a relationship between the x and theta variable. This is a relationship between the rate of change of x and the rate of change of theta. And that's why we call this related rates. I love you guys. I can see in your eye, you're like, oh, this feels not that bad, and it feels really horrible at the same time. I don't know. Now you just plug all the shit you know in, right? What's dx dt? 300? Oh, and here's, what do I not know? Theta. How can I figure out theta? And what do I want theta at a time when what? At 10 minutes. So isn't this the picture that represents theta at 10 minutes? So can you figure out what theta is? All right, and really, I'm kind of happy. I haven't done this problem since I made this worksheet, which is a long time ago, which is kind of nice. What did I do as I did this? I got to this point, I started plugging shit in I know, and I went, oh shit, I don't know theta. All right, let me go figure out what theta is, right? So what told me what to do right now is the fact that my equation needs to know what theta is. I'm like, I'm sorry, equation. I have no freaking idea. My equation actually needs to know, let me see if you guys are cool with this. What does my equation actually need to know? Doesn't it need to know what cosecant theta is? I really want some of you guys. Theta, isn't theta going to suck? Isn't theta going to be gross? Isn't theta not going to be nice? How would you figure out what theta is right now? Inverse tangent of 3 over 50, yes? Is that going to be a nice number? I put a lot of money on that not being a nice number. Okay. What is my what does this really need to know? Doesn't this really want to know what cosecant of theta is? So could you figure out what cosecant theta is? Still not going to be pretty, to be honest, but you can do it either way. Just takes one level away. I really want you guys to understand. There's a theta in the equation, yes? Take a step back. There is a cosecant of theta in that equation, yes? If I know either one of those, I can continue. If I know theta, I'll take the cosecant of it and square it. If I know cosecant theta, I'll square it. Do you see how it's a little better to know what cosecant theta is and to plug it in? What's happening to cosecant theta? Being squared, right? And then does all this other shit, right? Can you take a minute, figure out what cosecant theta is? What do you need to figure out what cosecant theta is? Pythagorean theorem. So that'll be what?
50.08.
Say again?
50.08.
I love you guys. No. It is, sort of, but not really, is it?
2509.
2509, I like it. Which one of those answers is more exact?
9.
Yes. Right? 50.08, is it really 50.08? Hell no. Doesn't it keep going for a long time? Hell yeah. Okay. I love you guys. All right, so we just did a lot of shit. All right. Look at what's so, I really want you to understand what's so beautiful about that. Let me stop. Let me come back. All right. Fill in this shit in just to make sure everybody's with me. I put 300 there, and then I look forward and I'm like, oh shit, I don't know what theta is. That would kind of suck. Theta's going to be kind of gross. Oh, I can figure out what cosecant of theta is instead. Couldn't I? That's all I need here. So what is cosecant of theta now? What's cosecant?
60.7.
Good. Rad 2509 divided by 3, right? Squared. Yes.
Why is that easier?
This is a lot easier. All right. I really want this to understand. So here's the triangle again. I want to know what theta is, right? I can look at it like that. I want to know what theta is. What would theta be? It would be the inverse tangent of 3 over 50, right? Then you have to plug this in here. Yes? Isn't that kind of gross? Is that like impossible? Of course not. Is it a little gross? Yeah. This is such an important thing to understand about math. When you're trying to figure out something to plug into an equation, you don't have to drill all the way down to I need to know theta. So often in trigonometry, if you just go, oh, I need to know cosecant theta, which is actually saying what? Oh, I need to know the ratio of two sides of the triangle. That's what cosecant theta is, right? That's such an easier thing to think about and to work with. All right, this is a tiny little point, but still. And look at how nice this is, yes? Isn't that nice? I don't have to put any decimal shit in there. I don't have to round. I don't have to be wrong. Because if you round, you're wrong. D theta D. Any of you guys ever taken science at all?
Yeah.
Aren't they particular about not rounding till the end? Because if you round in the middle of a problem, you're going to propagate that error. Have you ever heard of that, error propagation? If you're 0.1 degrees off in a boat, 8 hours later, you are lost. Yes? You are the next dumb show on CBS or something. Okay. Smoke monster. Okay. So then we get 300. Look, I can just work with this directly now. Negative 3, let's see, negative 3, 2509 divided by 9. Is that cool? So that is 3, multiply by 3, multiply by negative, divide by 2509, and that's going to be d theta dt. That 3 is not a part of this, by the way. Is that all right? I mean, I did a lot more by hand than I could have otherwise. And then I can throw it in the calculator, right? Why does it make sense it's negative? What's happening as the plane goes... Oh, this doesn't look good. What's happening as the plane goes away? The angle of elevation goes down as I follow it, doesn't it? So it makes sense that it came out negative because my angle is decreasing to the plane as it flies away. I lock it until it reaches the horizon, and then it's 0, and then it disappears over the horizon, and flat Earth people cry. Now, Shaboo. So it's whatever. I don't even care what it is. I mean, just throw that in calculator, get a decimal, whatever the hell it is. Yes? Oh, you guys are like, that was number 1, Jeff. That was number 1. There's a lot of good shit in there that you need to understand to be able to do some of this easier. Number 2 is actually easier. I don't know why I made number 1 the harder problem. I just did. Look at number 2. Look at number 2. I've got a relationship between volume and radius. What is this talking about?
Volume decreasing by minutes.
Good. So what's the symbol for this information? dV/dt. And you know, I really want to make sure you understand. Cubic centimeters, volume, minutes, time, dV/dt. It just matches this notation, matches the units. It's really, really nice. I'm not going to put units here because I got to do some math to it. I don't want the units in the way. So, and what's it asking for? And what's that in symbols? dr/dt. It would have sucked a little bit if I talked about diameter, right? Because then it would be dd/dt. I can't do it. dd/dt. There it is. Try to do the next step. I won't even say what it is. You can now start working on that equation. Let's see if you guys can do it. Oh, yeah. Anybody else need a copy of this or the practice test? Sure. All right, what are you guys doing?
dV/dt equals
Yeah. Derivative of this thing.
volume
4 pi. No.
4 pi r squared.
R squared. dr/dt. Right? Derivative of r cubed is 3r squared dr/dt. Real quick. Do you guys know the surface area of a sphere? 4 pi r squared. Real quick. So, the volume of a sphere, 4/3 pi r cubed. You've seen that before, yes? Even if you kind of forgot about it, 4/3 pi r cubed, hopefully it kind of like, oh yeah. If I, now real quick. If I, what's one way I can kind of increase the volume of this is I can apply a thin layer of tape over the whole thing, yes? So how much did the volume change by? It basically changed by the surface area. So the change in volume for a sphere is equal to its surface area. I'll stop. Okay. That's so cool. By the way, real quick, what's the derivative of the area of a circle? Pi r squared. 2 pi r dr, right? So 2 pi r is the what? Circumference. Same idea, right? If I do a tape around the thing, the circle's area grows by basically the circumference. So the derivative of the volume is equal to the surface area of the object. We're talking about what the shit. Okay, I'm sorry. So now this is much easier, yes? Because I gave you what you needed. You had the equation, you figure out the derivative. There's one thing you need to know. R, and I told you what R is. Look at that. So that's the kind of problem I'll probably give you on the test. This one is a more layered problem, obviously. This one's much more direct. I know what this is. I know what this is. I don't know what this is. Right? Just plug the 4 in for the volume because I'm losing gas out of the spherical balloon at this rate. 20 at a time when the radius is 24. By the way, real quick, I can't remember if the book does this. This is kind of dumb if it does, but make sure the units match, of course, right? Yes? If this was meters and that was centimeters, it's like, oh, come on, book. That's shit. But and now you just solve for drdt, right? The 4's cancel. So I get 1 over 24 squared pi. What is 24 squared? Thank you. What would the units be? Yes, centimeters, change in R, per minute, change in time. Minute, Jeff. That's why it's good to do what I just did. Keep yourself straight. Right? Everything's in centimeters and the time is in minutes. And then you just throw this in the old calculator. I mean, whatever, I don't care, right? Just throw it in the calculator. And I don't care about that part because, I mean, you should. I would probably say, give me an approximate answer, right? Because if you tell somebody, Johnson, how quickly is this changing? And you're like, 1 over 576 times pi, sir. I was like, who the shit are you, man? How far away you live? About pi squared. Go away. All right, sorry. Do you guys get that problem? Is that problem? That should have been number 1, but oh well, past Jeff just wanted to be evil. That problem is the classic related rates problem. I have a relationship between variables. I know how one of them is changing. I know the value of one of them at some point. Do calculus to get a relationship between the rates. Plug in everything you know. Solve for what you don't know. Sweet. All right. The first problem was you don't know everything you need to know. The relationships are a bit weirder, all that kind of shit, right? But this is your classic, basic related rates problem right here. And what's part B all about? Do part B. Go ahead and do part B. Oh, okay. All right, I like it. Yeah. Oh, do you know the answer? Hold on. Would have been easy to do part B before you did part A. Hell no, right? So what's the first step here? So I know the R is 24. I also know this. So what's the first step here? I mean, what is it they're asking me for? Let me ask you that. What would this look like in symbols? ds dt. So of course that tells me I've got to get it. Okay, this is awesome. What's the derivative of 4 pi r squared? 8 pi r drdt. So now you just got to plug in what you know. I know 8 pi, I know r is 24, and I know drdt is 1 over 576 pi. Very often I would like to, use this full thing because that's the most exact you could be. You're not propagating any error. Yeah. Because every variable in this is changing as the balloon loses gas. Isn't it? It's getting smaller. So isn't the radius getting smaller? So the big deal here is, am I taking the derivative with respect to r? What am I taking the derivative with respect to here? What is this the derivative with respect to? Time. What's changing over time? The surface area is getting smaller and the radius is getting smaller. So I really want this to make sense. Isn't S a function of time? Yes. Because as you wait, the balloon gets smaller, its surface area gets smaller, yes? Okay. Isn't radius a function of time? Yes. So won't this have to be a chain rule? You have a function of time in another function. So you do the derivative of the outside. The 2 comes down. And then derivative of the inside, dr dt. So this section is just putting together everything we know so far. And it's definitely big time chain rule because almost every variable in every equation is going to be related to time somehow. It's going to be changing over time. Okay, maybe. And then, of course, this is the part that I almost don't care about. You just throw that in the old calculator. I think it's going to be 0.33333. Did anybody do that yet?
59.
What is it? 1/3, yeah. Should be 1/3.
Oh.
Ruh-roh. Because the pi's cancel. This was 24 squared, right? So 24 cancels. 8, 24 is 3, I get 1/3. Yeah,
You did a lot easier than me.
yeah I did. Or sorry, well, because I have a few more years on you with the math stuff, so I know what to kind of look for. Yeah.
This is more of a personal question, but why did you look at that and say 0.333 instead of just saying 1/3?
Oh, because I thought maybe somebody would have put the whole thing in. You know what I mean?
Yeah.
Just to match with what I think people would have done. I mean, did anybody just put all the shit in the calculator? Anybody?
Yeah.
So that's what I was doing. I was like 0.33333.
Okay.
Okay. Just to match with people what they did in the calculator. Now, if I would have said 1/3, they would have said, oh, that's 0.3. Okay, I like it. So, I'm not going to do this one. We're going to do that one Monday, probably, right? So what I want to focus on now, so a problem like this one is most likely what I'm going to put on the test on Friday. And there should be problems like this at the beginning of section 3.9 homework. So that's why I was like, do the first 4 or 5 problems in 3.9. Finish it if you want to, but you don't have to. All right. Does everybody have, do you have it, Jeff? I don't know, I thought I did. Maybe I gave all of them away. Wait a minute. Does everybody have a practice test? Oh, there they are. Maybe need one? Yeah. Oh, shit. Let's see. We printed some more out somewhere. What do you want? Let me see. I think I have more, maybe. I had all the ones from last time, and I printed more out. So, you would think that would be enough. That is magic shit. Did I put it up in the? Did I put it up on Canvas too? Right. Oh, that's this. Okay. That's it. I don't have any more copies, man. But it's up on Canvas. Yeah. I'm not sure how I ran out. I had extra. All right. So the rest of the time is devoted to homework questions, questions from the practice test, anything, whatever you guys want to look at and focus on. It's totally open. So if you have no questions, we'll just head out. Everybody's ready for the test. Kick ass. It's up to you. Yes.
You do 1A.
Yeah. Tell me. What is it? Oh, I got it right here, I think. Got my answer key. Okay. Right. I think I rewrote it. One quick little thing, guys. One quick little thing. How would you rewrite this? No. How would you rewrite this? 5 over 7. That's had a few people flipping that around. But the root cuts it into so many parts. That's why it makes sense. It's like 1/7 of this thing. The root's on the bottom. Power's powerful. Goes to the top. Right? Okay. Because if you rewrite the roots wrong, then ruh-roh, you ain't going to get it. All right. So now I can do the derivative. What happens for that derivative? Negative 1/4, I like it.
Plus 4, it's x to the negatives like this.
Remember what I told you. Remember, shortcut 3 minus 4, negative 1 over 4. Negative 2 minus 5, negative 7 over 5. It's an awesome little shortcut. Is that all right? Okay, I like it. Okay. Anything else? If we just start marching through that, I might just give you the answer. Yeah.
I'm confused with the LN stuff.
Okay. Okay, so let me catch up to you. Natural log. So if I have a function natural log of x, what is its derivative? 1 over x. So the mistake people make, the reason I don't like the shortcut way to write if I have a function inside of the ln is it feels like it's its own thing. No, that's the definition. That is the derivative of ln. If you got shit inside, that's chain rule. If you got ln times something, that's product rule. If you have in the quotient, that's quotient rule. I mean, the rules don't give a shit what the functions are. So now that I know this, I know everything about ln. So if I had a problem like this, yeah, right. So derivative of ln of something is 1 over that something. Chain rule says you got it inside, you got to give it a turn, right? Do you get what I'm saying? Chain rule does not give a shit what the function was. It just says if there's an inside, it gets a turn, right? That's all it does. Nothing special about natural log, nothing special about any function. So what's g prime going to be? Yeah, I like it. Derivative sine is cosine. Cosine over sine is cotangent. Not really what we expected necessarily, right? But that's what it is.
Okay, so then with like F is product.
Say again?
For 1F, it's going to be product.
Oh, yeah. All right, so 1f. Does it look like this here? Oh, wait. Sorry. It started off like this, right? 2 ln 3 to the Like that?
It was
Oh, I missed out a sign, didn't I? Shit. All right, I got you. Let me try again. I'm trying to work backwards from my answer key, so it's not going so well. Hold on. All right. Okay, I see what it was. Okay. 2 ln 3 to the sine of 5x minus 3. That? Okay, thank you. Now, this would so desperately suck to do it the way it's given to me, because this would be like a chain rule inside of it would be 1 over this and chain rule. We're adding calculus knowledge about natural logs. That does not mean we forget everything else we know about logs, right? I kind of gave it away when I wrote it the other way, I just did, but what is it about logarithms that helps me do something about that sign? I can bring it down, right? Any log. What's up?
I don't remember any of that
Okay,
stuff.
so this property, in fact, real quick. Do you remember this property of logs? If I have log of some base b of something times something. Okay. Real quick, in case anybody else. What is a log again? What is a log? I like it. Less specific, less technical. So what is log base 3 of 9? What's log base 3 of 9? 2. Why 2? Because that is the power that 3 needs to become 9. So what is a log? A power. So what are the properties of logs? The freaking properties of powers, because logs are powers. What do I do with the powers when I multiply two things with the same base? What do I do with the powers when I multiply two things with the same base? So what's x squared times x to the 7th? You add them. So look at this property. This is how I teach this shit. Logs are powers, therefore their properties are the same as the properties of powers. Because that's what the hell they are. So this will be log base b of m plus log base b of n. So I really want to watch. The power on the product of two things with the same base will be the sum of each power. We know that shit. And there's a whole big proof I could do. I'm not going to do it. Just. All right. So of course, watch this. This is 1, 2. So what would this be? Log base b of, you can do it, Jeff, m to the a. I'm going to use this property somehow here. Stay with me. So what does m to the a mean?
M multiplied 8 times.
Exactly. Right? Stay with me. You with me so far? M to the a just means m times m, a times. So a could be anything. A is whatever power I want. All right, what does this property say then? Isn't this all just multiplication? So wouldn't that be log base b of m plus log base b of m plus log base b of m plus how many times? A freaking times. So what is log base b of m plus itself a times? Isn't that the definition of multiplication? Isn't that a times log base b of m? Maybe? Right? What's 5 plus 5 plus 5 plus 5? 4 times 5. Yes? In fact, multiplication is repeated addition. That's the fundamental definition of multiplication. This is like, so what does it look like happened? Ignore this shit. What does it look like happened? Looks like the a came down. And, just to really solidify this, what do I do with the powers when I raise something with a power to another power? Don't I multiply the powers? So doesn't this say this power times this power? It's still a property of powers. That's still what that is. Okay, whew, that was a neat trip. So, That's an incredibly important thing to know about logarithms, because now I could just bring that sign piece down. So I haven't taken a derivative yet. I'm just going to bring that sign piece down. Say again, sorry. Yeah, what did this say? It said whatever power is on the inside comes down. So that power is on the inside thing in natural log, so it can come down. Feels like cheating, but that's how logs work, because that's how powers work. What is this? A number. Not zero. So how many functions are in this? One. So it's going to be f prime is going to be the constant times, what's the derivative of sine of something? Cosine of something. Times derivative of the inside, which is 5. Chain rule, right? Derivative of sine is cosine of stuff times the derivative of stuff. It gets a turn. That's just chain rule. So again, let me write it out further. I'm going to rewrite this. So I put the 2 and the ln 3 together. Is that cool? I just put it out here together. It's just a number sitting out there. Derivative of sine stuff is cosine stuff times the inside gets a turn. So that's what it looks like in its full glory, right? That's good old chain rule. Is the inside just x? No. So it better get a turn at the end. Derivative of the outside function is cosine. Derivative of the inside function is 5, right? So the basic idea of chain rule is, so once I take that down, once I take that sign down, forget about where it started. I've got this. 2 ln 3 is a number, because it just kind of sits there. Sine derivative is cosine. Inside gets a turn. So now I can take that 5 and put it out here and make this 10. So dear God, if I give you a log problem, a natural log or whatever, if there's any simplification, yeah, shit, yeah. Shit, yeah.
Back up.
Say again?
Can you go back up just so I can see what
Let me zoom out a little bit. Yeah, let me go ahead. I'm going to go ahead and give you the answer key. It's in 2 parts. Do you think the actual test is going to be this long?
No.
Of course not. It's going to be longer. No, I'm joking. Kill myself.
Yes. Exactly that.
What's that?
Huh?
You saw my shoelaces going crazy? All right. some of you guys on your homework did what I said you might have to do. You turn your paper this way, right? Some of these problems you have to turn your paper sideways to get it all in there. I don't think I actually did that anywhere, but I could have probably. Yeah.
Did you go over part
Part
G?
G.
For the credit stuff?
What did it start off as?
Maybe X equals X to the power of C and X.
W.
W X equals X to the power of C and X.
All right, cool. So this was the last thing we did when we first talked about natural log derivatives. So you don't have to know the whole thing I talked about where it's two different forms and blah, blah, blah. What has always come to our aid when the variable is up in the exponent is logarithms. And it's because of that property we just talked about where it brings the power down. So if I attack both sides of this with an ln, how can I rewrite this side, of course? That can come down. And now it is doable. So it looks worse, but it's infinitely better because this is impossible and this is doable. Sorry?
Why does the X?
Oh, all right. So I don't have to write W of X. Okay. I like it. Just so it doesn't look like it's W times X or something as I'm doing my work. Yeah. So then now you attack this with what kind of differentiation? Implicit, fundamentally, right? So, yeah, derivative of ln W. Is that first step really kind of put it all together? You think you can go from there?
Yeah.
Yeah, I think I started here, didn't I? Is that where I started on the answer key? I can't remember. Okay, so some of those I kind of started at a position where I simplified things already.
I still don't really get 3 and 6.
Oh, okay. So what does 3 say? What does mine say?
It's
Sweet.
Finding the equation of a line that has a tangent on the curve of f of x equals x squared minus 9x and goes through 10 and negative 6.
Oh yeah, this is one of my favorites. Okay. It would be, Jeff. This is so subversively simple looking. But the problem with this is, so normally this kind of question I ask you, find the equation of the change in line to this at x equals 2. You plug a 2 in here, you know what the point is, you get the derivative, you know what the slope is, all good. Here, does that function go through this point? That's not what it's saying, right? Although my little quick thing. So find the equation of the change in line to this curve that goes through this point. So the tangent line goes through that point. Does everybody understand why this is a little more evil of a problem? That 10 negative 6 doesn't have shit to do with x squared minus 9x, right? I really want you guys with me on this. Yes?
How would it be written if it was saying that it goes, the function goes through that?
So normally this would say find the equation of the tangent line to this function at x equals 2. Take a derivative, plug in 2, find the slope, plug in 2 to this to find the point. Y minus y1 equals mx minus x1 if you want to. Right? Standard shit. And of course you guys have Jeff as a teacher. So Jeff said, oh, that's too easy. All right. This one, this point, ain't got nothing to do with that. All right. Stay with that. Does everybody understand how this is a different problem? I'm pretty sure there's at least one homework problem like this. Okay. So, real quick. If I draw a rough sketch, can somebody tell me anything about this function? What's it going to go through? 0, 0. factor it, and it also goes through.
-1.
Oh, I don't care.
10.
You're like, what? No, find the easiest things. What are the intercepts? 0, 0, and 9, 0. Yes? If you factor this, x times x minus 9, 0, and 9. Okay. And it's a parabola, so I basically know it looks like this, roughly, right? Make that point big, everything's fine. All right. Is this a good enough thing if I actually ask you, graph this? Shit, no. Shit, no. That's shit. That is pure shit. No scale. It didn't even go through that point. Is it good enough for this problem? Of course, I didn't say to graph it, did I? I'm just sketching it real quick, just to get a look at this thing. A rough sketch. Where's 10, -6? Somewhere over here, right? 10. It's going to be here, -6, somewhere over there. So I want to know, so isn't there a tangent line like right here that goes through there? And maybe there's one up here that goes through there? Looks like there might be 2 answers to this. Okay, let's just focus on one. Let's just focus on this guy. What's the slope of this line? And I love it. This is where you guys are like, I don't know. What point is this? 10, -6. What point is this? X. X squared minus 9x. All right, now listen, guys. Listen. This is relatively soon going to be an easy problem. Going to need to be an easy problem. Oh shit! I really because. All right. If you don't give yourself a rough sketch for this kind of problem, I don't understand you completely. Because with a rough sketch, I can now identify things, and I got a nice visual. Is everybody cool with the way I wrote this? Any point on this parabola is x comma x squared minus 9x. That's the output for any input. We've seen this kind of thing before. Why is that useful? Because can't I find the slope between these two things now? What does that represent? If I find the slope between these two things, what does that represent? That represents the slope from any point on this thing and that point. So what is the slope between these 2 points? You could do it. Yeah, you can do it that way, but let's keep my x squared stuff positive. Do you agree? So I can do x squared minus 9x minus 6, minus -6, over x minus 10. That is the slope between every point on this thing and 10, -6. That's what that represents. Is everybody, the more you understand what I just said, the more you understand all the calculus. What's the other? Yes. Yeah. It's not the definition of derivative because I didn't find the derivative of the function. I found the slope between every point of the function and some other point. Right? Okay. But what do I want to be true? I want the slope between that point and this point to equal the slope of the function at that point. What's the slope of the function at any point? So I want the slope of the function to equal the slope that I want. So I've got 2 different ways to get the slope that I want. I've got it from this theoretical kind of thing. It looks like it's here, goes there. I don't even have a scale. I have no idea if this is right, but it gives me a little, okay, that's the slope between any point and this point. To be the answer, I need, because isn't there a slope between this point and that point? Why do I know that's not the answer? It's not frickin' tangent. What makes it tangent is if the slope between the points is equal to the actual slope of the function. I really want that to make sense. So this is one way to find the slope. This is the calculus way to find the slope. I want them to be equal to each other because they're supposed to represent the same thing at some point. Yes?
If we use the big line on the right, that would
Yeah, because again, what's this point? This represents every point. So I could use any point I want to on this thing, to be honest. Because that represents every point on that parabola, yes? Does that make sense? Does everybody understand that this represents, in fact, this way of giving you a function and this way of giving you a function are equivalent. What does this way tell you? When the input is x, what's the output? This, right? Yes? What does this point tell you? When the input is x, okay, these are equivalent. These are the same frickin' thing. Because what is a function if not a collection of points that follow what it wants them to do? Yes, maybe? I love you guys so much. Why does this come up so much in calculus? Because calculus is all about slopes between points. So if I can write my function as a collection of points, I can find the slope between it and anything. Just like I did in this problem. So now I just got to solve this, which isn't that pretty, but you multiply that up, you pull over to one side, you factor, you get a couple answers. So try to see what I did. Either try to do it yourself or try to follow what I did on the answer key. Is that better? Even if like this much better. Is that this much better? Did I make it worse? Is it now worse than what it was before? I did. Okay. Bad, Jeff. I'm sorry. So this problem, I want to know what point on this parabola will have a tangent line that goes through this point. Yes? That's what I want to know. I want to know what point will have a tangent line that goes through this point. This one won't. This one won't. This one does. So there's every single point on this parabola, and there's the point that I want it to go through. So this is the slope. This is the slope of every possible line that is a point on the parabola, and the point 10, -6. Which ones of those will the answer be? The ones that have the same slope that my function has. This is the slope of every possible line, but what's the slope of my function? 2x minus 9. So I need the slope of the line to be the same as the slope of the function. That's what we're doing here. Yes? Oh, this here? Are you cool with that point? Are you cool with that point? Obviously, yeah. So what's the slope? It's going to be y2 minus y1, bam, over x2 minus x1, bam. I really want you to understand, why is that the same as algebra? Because that's what the hell a slope is. That's it. That's what the hell a slope is. Can it be something else? No, because that's what the hell a slope is. So what's the first thing we did is we brought limits in, used the same damn definition of slope, but we extended it to include every function no matter how curvy the damn thing is. Right? But didn't we start with the fundamental y2 minus y1 over? Because you can't change that shit, because that's what slope is. Sorry, I'm yelling at you. Especially up here. Maybe, yes? So that's why some calculus feels so simple, because the ideas it's built on are simple, but then we layer, so that's what makes it complex. Yes?
Can we do that extra step because the point isn't on the actual equation line? Is that the reason why?
Yeah. This problem is harder than the standard problem because that 10 -6 is not on the function itself. So let me show you what would a normal problem look like, right? I think somebody sort of asked me that. A normal problem that's not this hard, and of course this is nowhere near done, right? You got to solve it, all kinds of shit. No. So a normal problem would look like, find the equation of the line, tangent line. You see that? Yes. To this function at, what do you got, Jeff? I don't know, man. I'm yelling at you guys again. At -1, 10. You guys with me? All right, I don't even have, let me, at x equal -1. Right? And then you plug that in to get the point. You take the derivative to get the slope everywhere. You want the slope at what point? -1. So I get a slope of -11. I know the point is -1, throw it in 10. Then I can do my, whatever way you like. You can do this. You can throw it in and solve for b, right? Okay, that's the standard one. Why was this easier? Because the x value I gave you leads you to the point that is on this function. So it's all about a point on the function. The other problem is there's some point off here, off the function that I want my tangent line to go through. So I have no idea where on the parabola that needs to occur. So that's why that one that is on the practice test is so much harder. Yes?
So would we just plug that into the equation to see that it's not on the line of the equation and then do that?
No. So this is beautiful. If you solve this, you'll get 2 answers that both work. So you can give me either line you want to. I think I did both on there, didn't I, on the answer key? Because I just asked for 1. So again, if you multiply that up, -9 minus 29 plus 90. You pull everything to one side. That's factorable. You get 2 things. One is this, and the other one is further in.
Right. Sorry, my question was like, how did you know that the point wasn't on the equation originally?
Oh, this 10 -6?
Yeah.
Because when I throw a 10 in, I don't get -6.
Yeah.
Okay.
So you did that before?
You can if you want to, but it's the way that it's worded on the practice test. It's the equation of the tangent line that goes through that point. So that's what the tangent line does, right? If that point was on the function, that would be almost too easy.
Right.
Of a problem, yeah. Okay. Maybe. You guys look beat up. Sorry. Is every problem going to be like that? No. They're going to be worse, of course. You thought I was going to comfort you. No. I'm a calculus teacher. You kidding me? Yes, sir.
So on 3.5, when we talked about 47, there's like the circle equation one. When you take the derivative, you just get a bunch of like more variables, like instead of, because it was originally x minus a squared plus y minus a squared equals y squared. You just get a bunch of derivatives of the variables.
With this one? Wait, did you say 45? No.
Sorry, 47.
47. Are you worried about the h and the k stuff and all?
Yeah,
Those are constants, right?
Oh.
So the whole idea here is you're given a circle. So what's the center of this circle? HK. We don't know what the circle is, but we know that HK, whatever they are constants. So don't think that they have to be involved in derivative stuff.
Yeah, that was my problem.
Just like the R is going to be constant. So we're given a circle. I just don't know where it is or what it looks like, how big it is, right? But the H, K, and the R, whatever they are, they're constants for that circle. I'm not letting the circle like breathe or something. That would be horrible.
So if we take the derivative of those will all be 0.
Yeah.
Oh,
They're like any constant, yeah. So you don't have to consider them as part of your derivatives. They're just numbers. Yeah. Okay. I like that problem. I think we talked about that problem a little bit, but yeah.
Yeah.
Okay.
But
That's why every now and again I think the book is not the most, like for example, here, did they say this? No. So like A and B are constants, but see how they don't say that? Kind of assholes. R is definitely constant, we know. A and B are also constants, right? For example, I think you had to do 67, right? I can't remember which one you had to do. So like K is a constant down here. Yeah, so every now and C is a constant. Yeah, so that's a little, that's very evil, actually. Anything else, guys? Everybody know that I have my extra office hours today, 1 to 2:30 in the Math Study Center. You guys know that? I put it up on campus, my extended office, my new office or whatever. Anybody went in? I think several of you gone in for tutoring, right? We have one campus tutoring now, so you don't have to do it remotely. I got my normal office hours. I'm always in the classroom 8:15. Alright, so if you want to come Friday early, I'll be here. Just trying to tell you all your options where you can get help, right? Any other questions? I mean, we have a few more minutes. Yes? Oh, I put a plus 6 there.
Yeah, but you put out.
Oh, I totally did. Okay. So that shouldn't be there. Okay, I like that. So which one was that? That was this one.
H.
So let's see. I'm averaging about a 97 on my answer keys. So think right here. This is minus 6x. This is number 1h.
Yeah.
That's minus. Oh shit! I am like zoomed way. That's minus 6x, and this is plus 6x. And somehow I just forgot my minus 6x. So that should die. That should die. And that's so much better, right? I like it. All right. All right. If you're all questioned out, you can leave. You can head out. I love you. You guys are all looking at me.
Kevin abused. Are you getting this? Like that all day? It was so easy. I wasn't here yesterday. So like the last thing I remember was, oh, derivatives are fun. Yeah. I wasn't here Monday either.
Oh, there's only one function. And it has a function inside it, so there's no product. And inside here, there's no product.
And I don't think I touched the homework, so I'm doing
Inside the
homework
radical,
already.
there's one function.
I think I'm doing country right now. I've been lacking.
So, I mean, it's the difference between